This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
Look at almost any major manufacturing hub today, and you will see an infrastructure running on borrowed time. We still rely heavily on sheer mechanical force and intense thermal heat to alter materials. These legacy methods are highly inefficient. They require massive energy inputs, and they leave behind toxic chemical waste and heavy exhaust that permanently damage the surrounding environment. This creates a severe strategic vulnerability. Global supply chains are tethered to the slow, physical shipping of volatile chemical processing agents. If those shipments stop, production stops. But there is a way to bypass these chemical dependencies entirely by harnessing the fourth state of matter, plasma. Instead of forcing a reaction with heat or acid, plasma allows us to channel raw energy directly into an atomic lattice. It rewrites the surface structure of matter at the molecular level without any mechanical friction. Deploying this energy has traditionally required massive, single-purpose facilities to keep the discharge from becoming uncontrollable. These high costs and technical fragmentation have kept global manufacturing dependent on the same chemical processes used for decades. The MPR-Σ1 platform was engineered to centralize that control. Previous engineers tried to manage plasma's instability physically or chemically. The MPR-Σ1 treats it purely as a strict mathematical control problem. At its core is a unified resonant control system, a digital feedback loop designed to regulate the energy before it ever leaves the device. Every microsecond, the system monitors raw voltage, current, and temperature, instantly outputting a flat-lined frequency wave. By adjusting this frequency, it locks high-energy fields into a stable mathematical boundary that deflects pressure and completely eliminates catastrophic electrical arcing. By domesticating that volatility at the source, the MPR-Σ1 turns an unpredictable scientific phenomenon into a highly reliable, reproducible engineered primitive. Because the core is perfectly stable, attached hardware can be swapped out. One single base station can now drive entirely different physical states. Attach head A and the system produces a precision plasma jet. Sweeping across a surface, it modifies the microtexture in a single pass. This specific activation prepares materials for industrial adhesion without requiring a single drop of toxic chemical primer. Swap that out for head B and the core drives a highly portable, handheld air discharge unit. This configuration generates reactive species right from the surrounding air, allowing field units to neutralize biological threats anywhere with zero external gas dependency. For extremely low-tolerance environments, Head C is a micro-machined array emitting a dense, uniform glow, engineered specifically for advanced aerospace propulsion and microsensors. And finally, Head D converts the system into a continuous packed bed reactor, built to execute industrial-scale environmental purification in real time. You no longer need 4 separate specialized factories. A single unified core now projects precise processing power across the entire physical spectrum. That level of microscopic engineering flexibility dictates how this technology deploys globally. The initial operational launch is anchored at the TU Sofia Research and Manufacturing Facility in Bulgaria. As we can see on this deployment map, from this primary node, the system establishes a highly scalable manufacturing pathway, tracing outward to supply standardized manufacturing hubs across the European Union. Looking at these rising market indicators, the financial mechanism at play is multi-market capture. Because the core hardware is identical, scaling production drops costs across the board. This single platform simultaneously disrupts medical sterilization, aerospace defense, and global environmental purification. By collapsing these historically siloed, multi-billion-dollar markets into one unified hardware ecosystem, the MPR-Σ1 lowers the financial barriers to advanced manufacturing. By unifying these disparate regimes, the MPR-Σ1 converts plasma from a specialized experiment into a versatile industrial standard.